Okay, Assalamualaikum. So in the lab 9, we studied three sensors which are used to find mainly the rotational speed. First one is slotted opto transducer, second one is reflective opto transducer, and third one is Hall effect transducer or Hall effect sensor. Uh, it is lab number 8 in the student manual, but the way we are doing the lab, it is lab number 9. Okay, so let's see how slotted opto transducer works. It consists of a transistor and a photo and a IR LED. So what basically happens is when IR radiations falls on phototransistor base, it conducts. When it conducts, current passes through the resistor, so the voltage appears on the resistor. In parallel to that resistor, we have connected an LED along with a protective resistance. So when the IR radiations falls on the phototransistor base, the LED glows. So this is the working of the circuit. So how basically we will find the rotational speed with the help of this circuit? We will use this disc with a slot. We will uh, connect this disc on motor's shaft. If this is the motor's shaft, we will apply the disc on it, this disc with a slot. So when the shaft rotates, the disc also rotates. When the slots appear, the IR radiation falls on the phototransistor base and LED glows. So in one rotation, LED glows only one time because one complete rotation has only one slot. So we will just check that in a minute how many times the LED is turning on, then that will be the speed of rotational speed of that particular motor. We can also use a counter on the output. We will connect a counter because you know that you have a limit to find the rotational speed with the help of LED. If the rotational speed increases that limit, you won't be able to judge its switching. So when the rotational speed is increased such that it is not distinguished with the help of LED, you can connect a counter. So you need a DC motor and you need a potentiometer to control its speed, and obviously you need a slotted opto transducer to find its RPMs. So for example, this is the motor and this is the shaft, and on the shaft you have this slotted opto sensor. So this is a slot here, right here. When it moves between that IR LED and phototransistor, like here is the IR LED and on this side you have a phototransistor. When the slot comes between them, the LED is turned on. Let's check whether it is happening or not. See, whenever slot appears, the LED turns on. So you can also connect the counter as well. So I'm not making the complete circuit because this is only a summary. First I will give it 5 volts. See, it's blinking but you can't read at how many times it is blinking. So you need a counter. You will connect the output node with the counter. We will switch it to the seconds in the second switch to the count and then press the reset button. So it will show you the number of rotations per second. You will multiply it with 60 to get RPMs. Now what if I will give it 12 volts? So basically its speeds increase. Now you will press the reset button again. So this was slotted Opto transducer. Second one is reflective Opto transducer. Almost working is same. Circuitry is same, working is a bit different. It also contains a phototransistor and IR LED, but the assembly is different. In this case, IR LED was here and a phototransistor was here, and in between there was a disc with a slot. In this assembly, IR LED and phototransistor are placed like this, just like the ultrasonic transmitter and receiver assembly. So in this case, when the object or the disc cuts the field of IR sensor, then the LED will glow, because if something pass from their field there, then the IR LED will then the IR radiation will reflect back to the phototransistor becomes conductor and LED will begins to glow. For this particular experiment, the disc is shaped like this. The disc is divided into 3 divisions or 3 semicircles, 3 circles basically, smaller circles, not semicircles. This is A, this one is B, and this is C. Now the disc has the black regions, which are, as you know, that black is the universal absorber. Radiation do not reflect back through the darker region. So basically when this region will appear in front of this sensor, the IR radiation will not reflect back, and so the LED will not glow. So basically in this assembly we have 3 sensors. First one is mounted here, second is mounted here, and third one is mounted here. So let's assume the position 0. In position 0, all of the circles that is A, B and C has the darker region, so neither of the LED will glow. So we can say that at position number 0, no LEDs will glow. It means the output is 0 on all the 3 sensors that are mounted in front of these 3 regions. Now consider position number 1. Here A region is reflecting while B and C is again absorbing it. So only the LED connected with the phototransistor A will glow, the remaining will be turned off. So this is basically the working of the reflective optotransducer containing this disc. Let's check its working. See, again this disc is mounted on the same shaft with the pattern that I have just told you, and these are the 3 LEDs, and this is the sensor. There are 3 sensors, first, second and third, all piled up on each other. So basically let's assume this region, this one. As you see, there is no darker region. So all of the 3 LEDs will glow, region number 5, and this is happening here. Similarly, when the respective position appears, the LEDs of that respected position will glow. This assembly is used to find RPMs as well as exact angle of the disc, because every angle has the different output. If you want to increase the resolution, you can increase the number of patterns. So this was all about reflective opto transducer. Third one is Hall effect sensor. Before understanding Hall effect sensor, first you need to know what is Hall effect. Hall's effect or Hall effect. Consider a metallic disc connected with a battery. So the current will begin to flow because the disc is metallic, rectangular disc. The current will flow like this. If you talk about the conventional current, that will move from positive to negative. If you connect the voltmeter between these two corners of the disc, you will not get any voltage, because there will be no potential difference, because there is no the whole disc is neutral. The charge will only appear when the negative ions or the negative charges are slightly greater on one side and positive charges are slightly greater on the other side, which is not happening right now, but it will happen when you bring magnet near to this disc. When the magnet comes near to the disc, according to the Fleming's left hand rule, if your middle finger indicates the direction of magnetic field and the index finger indicates the direction of current, then the thumb will indicate the direction of force that the moving charges will possess. So the current that was previously flowing undeflected will now be deflected towards the region where force was being exerted. So due to which the positive charges will be slightly greater on this side and the relatively negative will be slightly greater on the other side. So then the voltage will appear. So this assembly is used to basically measure the magnetic field, but for this particular lab we will be going to find the RPMs. So this is the Hall's effect sensor. So Hall's effect sensor has the metallic disc that will be beneath this circular disc, the black one. This is the disc. Basically this is the IC containing that disc, and the magnet is mounted here. This is the magnet. So on one rotation, magnet will cut the region 1 times, and so the voltage will appear between negative and positive terminal 1 times. You will connect the instrumentation amplifier and then amplifier with a particular gain so as the output is readable, because you know that the voltage is appear but it will not be as much readable, so you need to amplify it, and then you will give it to the counter, and the remaining process will be same. You will connect the DC motor, then the instrumentation amplifier between these two nodes, just like this, either instrumentation or differential amplifier, and then another amplifier and at the end the counter, and then you will turn on the DC motor to check the RPMs of it. This was all about lab number 9.